Okay, this is a walkthrough of problems where you have to use the constant acceleration equations. So for this problem, let's say we have a horizontal motion. So the object is just moving side to side. And let's say that the object starts moving to the left. At 7.5 meters per second. And so it's traveling to the left, and it comes to rest after it travels a distance of 15 meters. And we want to calculate two things. First, how long does it take to stop? So that's measuring the elapsed time. And then second, what's the velocity of the object when it's traveled 10 meters? So, it stops after it travels 15 meters. When it's only traveled 10 meters, what's its velocity? And we're going to do this, each of the parts of this problem independently. So I'm going to start out with A. I'm not even going to worry about the fact that B is coming. For these kind of problems, there's a set of steps that you follow. The first thing that you have to do is you have to choose what's going to be your instant for time equals 0, your instant for time final, your position equals 0, and your position final. Remember that the time equals 0 instant and the time final instant, think of those as when you click a stopwatch on to time something, and the time final is when you click the stopwatch off. So that's what that means. Always think of time equals 0 and time final as this stopwatch. Okay, so the first thing you have to do is choose those. Let's choose those time equals 0 and time final. That has no flexibility. So pause the video for a second and figure out what you want to be the instant for your time equals 0 and what you want to be the instant for your time final. Okay, well, we're making these choices based on the instance where we have information and instance where we're trying to calculate information. We have information at two spots. We know when the motion starts, we know the speed and the direction of the motion. When the thing comes to rest, we know the speed of the motion and we know how far it's traveled. And so the only way to do this problem is for your time equals 0 to be at the instant that the object is moving at 7.5 meters per second. And for your time final instant to be the instant when the object reaches rest. So if you chose anything other than those, excuse me, as your time equals 0 instant or your time final instant, figure out what you were thinking that got you there, because these have to be your choices for those two. The other two choices you have to make, you just have to make those to be consistent, but those have more flexibility. So I'm going to tell you what I'm going to choose. I'm going to choose my position equals 0, location to be the object's location. When time is equal to 0. And my positive direction, I'm going to choose that in the direction of motion, so I'm going to say that's to the left. Okay, that's the direction the object is traveling. So if you want to see this in a drawing, the object is going from here to here. This distance is 15 meters. I chose my 0 position to be here, my positive direction to be this way, and that means if you start at 0 and go 15 meters in the positive direction, this location has to be positive 15 meters. And this would be at 0 seconds there, and we're trying to calculate this instant. We don't know what this is. That's going to be our time final. Now that we've made those choices, we can think about what variables we know and what variables we want. So I'm going to list out the order of variables. I just always do it in the same order so I don't forget things. So the possible variables that we could know are time final, acceleration, p initial, p final, v initial, and v final. And let's think about these one by one. Okay, so time final. Time final is what the stopwatch says at the instant that you've chosen to be time final. Do we know that? Pause the video and see if you know whether you know that or not. Okay, we don't know time final. In fact, how long does it take for it to stop? Notice that what we're looking for is what the stopwatch says when the things come to rest. So that's what we're trying to calculate. Next, do we know the acceleration A? Pause the video and think about whether we know that. No, we don't know that. What about P initial? So remember, P initial is the object's position when time is equal to 0. So pause and see if you can figure out the value of P initial if we know it. Okay, at time equals 0, the object, so at time equals 0 here, the object is at 0 position. So our PI is 0 meters. Now the next one, we're just going through this list. Do we know P final? That's the position at time final. Pause and see if you know a value for that. Okay, well, at T final, we don't know what the stopwatch says, but we do know that the object is going to be at this location 15 meters away, and we've already figured out that the position of that location is positive 15. So P final is positive 15 meters. Okay, now do we know V initial? That would be the velocity at time equals 0. Pause and see if you have an answer to that one. Okay, well, we're given that the object is moving at the instant that we chose as our time equals 0, the object is moving 7.5 meters per second. That's a speed, so now you also have to think about the direction. Is it moving in the positive or the negative direction at this instant? It's moving to the left, and that's the direction we chose to be positive. So our initial velocity is positive 7.5 meters per second. And then last, do we know the final velocity? That's the velocity when time is equal to 0. If you look at this little diagram, we're looking for the velocity when the object is here. And we're told in the problem that it's at rest, so v final there is equal to 0. Okay. So the next thing we need to figure out is whether there's an equation that lets us solve for TF, that has TF in it, and everything else in it is known. So look through those 3 constant acceleration equations and see if there's an equation that would let us solve for TF. Pause the video and look through and see if you can figure out the answer to that. The answer is no. There's nothing that'll let us solve for TF yet. So when that happens, what we are going to either look for is an equation that lets us solve for TF or an equation that lets us solve for A. Well, we already know we can't solve for TF. So let's look for an equation that lets us solve for A. So pause the video and see if there's an equation that'll let you solve for A. The answer is yes, this one will. 2a times the quantity pf minus pi is equal to vf squared minus vi squared. So let's set this up. We have 2a times the quantity pf is 15 meters minus pi is 0 is equal to 0 squared minus 7.5 meters per second squared. And so if we multiply out the left side, we have 30 meters times A is equal to 7.5 squared is 56.25. Notice that that negative is not squared. That's outside the parentheses. So we have negative 56.25. The meters per second are inside the parentheses. So this is meters squared per second squared. And now we're just trying to calculate A. So to do that, divide both sides by 30 meters. You have A is equal to, I'm going to write this out as negative 56.25 meters times meters over seconds times seconds. And dividing by 30 meters is multiplying by the reciprocal. So you get those meters to cancel. And you get an acceleration of negative 1.875 meters per second squared. Okay, here's a question. Does it make sense that our acceleration is negative? Yes, it does, because notice that the object is moving in the positive direction. The velocities are positive. And the object is slowing down from some speed to 0 speed. And so the acceleration needs to be the opposite sign of the velocity. The velocity is positive, the acceleration needs to be negative. So that all makes sense. Okay, now let's go on to part B. And let's start over again with our choices of time equals 0, time final, position equals 0, and positive direction. So are there any is there any reason that we would want to change our choice of time equals 0 or time final instant? So pause the video and think about that. Yes, we do have to change. Our time equals 0 can still be when the speed is 7.5 meters per second. But our time final has to change because we're looking for information now at a totally different instant. And you can never do a calculation at an instant other than your choice of time equals 0 and time final. So our time final is going to be when this thing has traveled 10 meters this time. Our position equals 0 and positive direction can still be the same as they were. Position equals 0 is going to be just like it was. The object's location at time equals 0. And our positive direction we can keep the same. And let's go through what we know and what we want. One thing I want you to notice is since we have the same meaning for time equals 0 and the same position equals 0 in the same positive direction, all of our initial stuff that we knew before, we still know. So position initial position is still 0. Initial velocity is 7.5. We've calculated the acceleration, and it's a constant acceleration problem, so that'll be the same. So pause the video and take a minute and see if you can fill out this table of what we know and what we're looking to find. Okay, time final, we don't know how long it takes for it to travel 10 meters. The acceleration, we know we calculated negative 1.875 meters per second squared. Our initial position is 0. Our final position, so if you look at this object, we're talking about starting at 0 and moving 10 meters in the positive direction. So our P final is going to be positive 10 meters. Our initial velocity is going to be positive 7.5 meters per second. And we're looking for V final. Okay. Now we have to figure out if there's an equation that'll let us calculate V final. Pause the video and see if you can find an equation that has V final in it and everything else in it is known. Okay, well the equation that'll work here is 2a times the quantity Pf minus Pi is equal to Vf squared minus Vi squared. That's the only one of our 3 constant acceleration equations that doesn't have T final anywhere in it. And so we have 2 times negative 1.875 meters per second squared times the quantity 10 meters minus 0 is equal to Vf squared minus Vi squared and so if we multiply out the left side we get negative 37.5 0.5 meters squared per second squared. And on the right side, we have VF squared minus 56.25 meters squared per second squared. Now we want to get VF squared by itself. So add 56.25 meters squared per second squared to both sides. And you get that positive 18.75 meters squared per second squared is equal to VF squared. And now the last step is just taking the square root of both sides. So VF is equal to the square root of the square root of 18.75 Remember that if you're taking the square root of a variable, the answer can be positive or negative. So we get positive or negative 4.33. The square root of meters squared per second squared is just meters per second, like we would expect if we're looking for a velocity. And the last thing you have to do is figure out physically what makes sense, a positive answer or a negative answer. Pause the video for a second and see if you can reason out which direction this is moving. Okay, well, this object is, it starts out moving to the left and slowing down, moving to the left the whole way. When it passes 10 meters, it's still moving to the left. Left is positive. And so our answer for the velocity when it's traveled 10 meters is positive 4.33 meters per second.